Greetings and welcome once again to my new calculus channel. My name is John Gabriel, and so today I'm going to be discussing a very simple proposition with you. But before I do, I want to make some comment about the way things have been done in the mainstream. So, for example, someone who's a valued member of my channel, this person here, commented one way I came across to reason about the shortest path was making use of the triangle side length inequality and induction. So notice how complex those things are. And it's not his fault that that's the way he learned, but that's the way most of you understand these things. And the sum of two short sides of a triangle will always be greater than its third side. I think it means not its hypotenuse. And so every path could be broken down this way, leading to a sum which will represent a greater distance than the straight line. So, and I responded, yes, but one of the proofs is found in Proposition 20 of Book 1, and its main approach is through the reasoning that a longer side has a bigger angle. So this very simple idea that a longer side has a bigger angle is the clever way of showing the so-called triangle inequality, okay? And I'll show you how it's done in a moment. So, what did Euclid do originally? Well, look at Euclid's proof here. It's quite long-winded and drawn out. And of course, I think I'm one of the only humans, in fact, maybe even the only human who thinks that the elements should be rewritten. And there's definitely no need for the elements of Euclid to be retranslated because the translations that have been made are about as good as they get. We need to rewrite the elements so that we can simplify them and make the proof shorter and make a lot of things easier and help mainstream professors, mathematics professors and teachers actually understand geometry for a change. That's why we need to rewrite the elements, because they've never understood the elements. There was no prologue. I had to write the prologue. I, John Gabriel, had to write the prologue. And so we've come a long way. We've gone over on a tangent in mainstream mathematics where everything now is dependent on the garbage of set theory and the Zermelo-Fraenkel axioms. Okay, total garbage. Now, let's see how this all comes together. So basically, the idea, which Euclid proved in an earlier proposition, is that a bigger angle, this green angle, supports a longer side, the blue side. Okay, so the bigger the angle gets, the longer the blue side gets. Okay, the shorter or the smaller the angle gets, the shorter the blue side, right? No blue side, longest blue side. And these don't have to be equal, as you'll see in a moment. This is an isosceles angle, but they really don't have to be equal. Okay, so let's see how we can prove this. So really what we're required to prove here is that this side here, A, plus this side here, C, is greater than B. Okay, that's what we're required to prove. And what we can do is a clever little trick. We can extend side A. And why can we extend side A? Because number 2 requirement, not axiom, says we can extend a line. And there's another proposition which says we can extend it to any given length we want. How's that? Well, it's basically the same as just taking a circle, right, and just extending it that length there, see, where this is the radius of the circle. That's how simple it is, okay? So, oops, what's happening there? I need to get out of, right. So we can extend any line by any given line segment, and we use the circle to do that. Now, so if we make this side here, this red side here, equal to C, then here's what happens. We have that these two green angles are equal because it's an isosceles triangle here, okay? And we say that side B, this side here, B, is subtended on 37 degrees, okay? And then A plus C, which is the same as this A plus this side here, is subtended on this big red angle, which is 77.79 degrees. So by the fact that the greater side is always subtended on the greater angle, we have that A plus C is greater than B. Do you see how simple it is? And of course, you could change that for any other angle that you like. Okay, doesn't have to be any particular angle, triangle. Any particular triangle can be any triangle that you like. Isosceles, equilateral, doesn't matter. So that's pretty much it. And now I'm going to leave you with a question. But before I do that, I want you to think about what I've just shown you here. Okay. So what I've just shown you here is made very, very complicated by those orangutans in mainstream academics whose names are math professors and math educators. They don't give you the simple stuff because they've never understood it. All right. And so the question I'm about to give you is this. Why is it that we can say that the two shorter magenta lines, these two shorter magenta lines, are subtended on smaller angles, so the sum of their lengths still can't be longer? Why is it that we can't say because a bigger, if the sum of their lengths is longer than the blue line, then why is the sum of the angles that they're subtended on, this angle and this angle, not bigger than the green angle? Why is that the case? Well, I'm going to let you answer that. But that's where I'm going to stop now. If you're not already a subscriber to my channel, become one. Click like on my videos. I'm very, very persecuted by the mainstream. They won't even allow me to put a Wikipedia entry on the new calculus channel because they decide, being the high priests and cult that they are, what is remarkable and what is not. So Wikipedia is not an encyclopedia. It's just a pile of crap. Now, anyway, before I go off on a tangent, if you're not already a member of my channel, you can join the channel as an ordinary subscriber, or you can join the members only channel. Okay, so the members only channel means you can go to any particular video, just click on the join button. Okay, this join button here, like so, and for €5 a month, you can get access to the best math content in the galaxy and probably in the entire universe. So it's just a cup of coffee, the price of a cup of coffee every month. That's pretty much it. I'm John Gabriel, and this is New Calculus Channel. Until next time, goodbye.